morning, guys. So, as part of chapter 1, we're going to discuss matter and its different physical properties. Okay. So, as part of physical properties, we'll discuss different states of matter. Okay. Effect of temperature and pressure on the states of matter. Boiling point we'll discuss, followed by melting point, and finally, important concept which we will discuss is latent heat. So, all these concepts are very important, and I have designed my lecture in the form of questions and answers. So hopefully you should enjoy. So thank you. The very first thing which we're going to discuss in this chapter is what is matter. So here is the definition of matter I've written for you. So anything which occupies space and has mass. Yeah, it is as simple as that. It's called matter. So matter can be seen from two aspects. It can have physical properties as well as chemical properties. So in this chapter we're going to talk about physical properties of matter. Okay, this will be taken care later. So let us take a question. What is the nature of matter? So there are two options in front of you, particulate and continuous. So let me make you understand what is continuous and particulate, and then we'll jump here. So see, this is continuous. So continuous is something which you can assume to be consisting of blocks. You can say it consists of series of blocks, and there is no space in between. And the green boundary represents it's a piece of matter. This is a piece of matter. Okay. So if the nature of matter is continuous, that means at microscopic level, the particles of matter will be cascaded in a series of blocks, and there will be no space in between. Yeah. And if it is particulate, that means the particles of matter exist with each other, and there are space available in between them. Okay. So in early days, scientists were not sure of the nature of matter. What is the nature of matter? Is it continuous or is it particulate? So they perform various experiments. Yeah. So let us perform one experiment. You too can perform in your kitchen. So what we'll do, we'll take a glass of water. Okay. And we'll fill it up with water, drinking water. Okay. Add a spoon of sugar to it. So what you will observe is, you will observe that the crystals of sugar settles down at the bottom of the um, glass. Agree? Yes, this is how it happens. So after that, what you should do is you use a stirrer. You can use one stirrer. You can stir this volume using a spoon, tablespoon. Just stir it. Okay. So what you will get after that? You must be doing it, I know. You will find that no more sugar crystals exist in the glass. Yeah. Now the question is why it happened. So that means the crystals of sugar got dissolved in the volume of water which we have taken in this glass. Now the question is why it got dissolved, or basically we are trying to understand what is the meaning of dissolving of sugar in water. Yeah. So actually what I'm trying to say is that both, let us go by this view first. Consider that, let us agree that matter is particulate in nature. That means be it crystals of sugar, or be it water, or be it air, whatever it is. Okay, it will consists of particles. Yeah. So I am taking a small volume of water from here. I'm taking small volume of water and we are going to analyze this particular volume of water, small volume of water. Yeah, you can see under microscope. So it will appear that this volume of water, this one 2 or 3 drops of water consists of numerous particles. Yeah, this consists of numerous particles, various number of particles, and in between particles there are sufficient space exists. Do you see that? So what happens when you give stir to this sample? The crystals of sugar gets broken down. When the crystals gets broken down, what happens? The sugar also is particulate in nature. We have agreed with this presumption. So that means let us take one crystal of sugar at a microscopic level. So let us analyze it. So this will also look like this. Yeah, one crystal of sugar will consist of various number of particles. So when we give stirring using a spoon, some crystals of sugar, yeah, get filled up into the space which is available between the particles of water. This is, what is this? This is water, and what is this? This is sugar. Got my point? So this is how dissolution of sugar took place. So now come back to this. Let us agree that water is continuous in nature. What could have happened if water is continuous in nature? First of all, there could not have there could not have existed any space in between particle of water. So no space. All the particles of water are cascading to each other with no space in between them. Yeah, no space, something like that. Okay, go on. And similarly, crystal of sugar will have the same kind of structure. So when you give a stirring, the possibility is that some particles of sugar, okay, from could have tried to dissolve into um, water, but since there is no space available in between the particles of water, so sugar could not got dissolved in water. Yeah, but this is not the case. Has this happened? No. What happened? We saw that the sugar got dissolved thoroughly in the available volume of the water. So that means the nature of particle is particulate. So this is how scientists prove that the matter consists of particles which have space in between them. Now it depends upon the state of matter, how much space lies between them. I mean, is it solid, gas, or liquid? So we'll take that part later on. The next question which we're going to take is, why do matter exist in different states? Yeah, that is in the form of solid, liquid, and gas. So before we answer this question, we need to understand the characteristics of matter. So every matter has three important characteristics, or you can say these three are the parameters of the particles of matter. Yeah, these three are the parameters or characteristics, whatever you say. Force of attraction between the particles of matter, space between the particles of matter, kinetic energy, energy level of the particles of matter. Yeah, since we will be using these terms frequently, so let us adopt a short form of this words. So force of attraction, going forward we will use letter F, small, and for space between the particles we'll use S, and for kinetic energy we'll use simple E. Yeah, let us take an example of water as matter. Okay, so it has different states. In solid state it exists in the form of ice, we know that. In liquid state it exists in the form of water, and in gaseous state it exists in the form of vapor. Just consider this. Yep. So the question is, why do ice exist in the form of solids, water exists in the form of liquid, and vapor exists in the form of gas? Okay, so to answer that, we need to understand that the the parameters of matter which we just discussed now has different values. Okay, across three different states of matter. So that is the reason why matter exists in different states. Yeah, I've just drawn a table in which I have shown this column is for matter. This column represents the parameters. We have three different parameters: force of attraction between the particles, space between the particles, and energy level of the particles. So in between this three parameters, force of attraction between the particles are the driving factor, you can say. This is a driving factor. Space between the particles and energy level, these two factors depends upon how much is the strength of the force of attraction between the particles. Yeah, so this is the driving factor. So let us adopt a scale. It's a very simple explanation I'm trying to give. 1 2 3. We all know that 3 is highest and 1 is lowest. Okay, so if I ask you to allocate value of force of attraction in the state of solid, so how much value you gonna allocate? 3. And how much value you will allocate to gas in the gas state? 1. It'll be intermediate. Yeah. So since the value of force of attraction is highest between the particles in the solid state, so that's why the space between the particles are lowest. You can say it is 1, and that's why the energy level is lowest. So similarly, the force of attraction between the particles in the gaseous state is lowest. So sufficient space are available in between the particles. That means it is 3. List force of attraction is force of attraction exists between the particles. So particles can fly away from each other with greater ease. You can say particles have the energy level of particles is highest rather, is 3, and liquid is in the intermediate state. So by seeing this table, you yourself can explain the things why it exists in different state. So the answer which you can write in your exam is the magnitude of three parameters. Yeah, that is force of attraction, space, and energy levels are different for three different states of matter. And you can suffice this example, and you can draw this particular table if you want. So that will explain. The next question which we're going to take is, why gases are highly compressible? Yeah. Answers I have written is, so let us understand it. I will revise it later on. So as we have seen in gaseous states, yeah, the force of attraction between the particles are the least. It is 1. Yeah, the least. So particles, so sufficient space, like too much space is available between the particles, you see, right? And also the energy level is quite high. Yeah. So if you apply pressure, suppose you take gas here in a compressible chamber. Yeah, you put some gas and you have a piston applied over this, and it has some gas particles in it. So initially, how will they exist? Like this. You can apply high pressure. Why? Because too much space is available between the particles of the gas. So finally you can compress it to this level. So this is what I have written. Too much space exists between the particles in the gaseous state. Yeah. So because the force of attraction is the lowest, right? So due to too much blank space between the particles, the gases can be compressed easily. So you can suffice few names of compressible gases. You can use LPG, which we use in our kitchen, and CNG. Next question is, what is diffusion? Why diffusion becomes faster with the increase in temperature? So first of all, we'll try to understand what is diffusion, and then we'll take a question upon it. Yeah, we'll revisit it, not a problem. So just pay your attention here. Suppose this is a fluid. So first, actually, this is a fluid. This diffusion kind of thing which we are considering here. So all this takes place with a kind of matter which is called fluid. So fluid means which flows. Okay. So what are the type of fluid? So you can say all liquids comes under fluids. All gases are also fluids, because both gases and liquids flow, right? Agree? So this is a very important concept. What is fluid? So we should know what is fluid. Fluid is a matter which flows. Liquids and gases are its type. They are simple as that. Okay, so now let us jump on to understand what is diffusion. So diffusion is very simple phenomena. So let us take so consider this is a drop of water. Okay, I've taken a very simple thing, drop of water. Okay, so a drop of water means I'm taking just one drop at a microscopic level. Yeah, so one drop of water consists of millions of particles. Okay, millions, billions, trillions. It's a large number of particles. Yeah, see they have. So anyway, I can't draw millions of particles here, so this is just symbolic. So we see, and we already know that there exists space in between the particles of liquid or gas, or particularly fluid. Yeah, so what happens, and we also know that matter has three important parameter: force of attraction, space between them, and energy level. Yep. So because of having kinetic energy, every particle has kinetic energy. Particles keep on moving. Okay, and suppose consider this particular particle. Just I'm taking an example. Consider this particular particle. Okay, over a period of time, like after a few seconds, you will find this particle here. Now this particle will keep on moving and will reach over here. This particle will keep on moving and will reach over here. So this is an example just for one type of particles. Okay, one particle which we took. This happens with every particle which is present in this sample. So what we see, what we notice, that particle keeps on moving because particles have kinetic energy, and they used to fill up the space which is available in between the particles. So consider now imagine that you are having two different type of substances, and two different type of substances means I've taken water. This is plain water. Okay, water also will be having its particle. Suppose this indicates drop of this indicates particle of water, and you have added a spoon of sugar with it. Crystals of sugar will keep on dissolving. Okay, and finally these are the particles of sugar which will keep on filling up the space. Okay, filling up the space which is available. So this red dots are the particles of sugar. See, initially it was at the bottom of the glass, but slowly when you give a stirring, okay, when you give a stirring, it will fill up the space. Why? Because the particles have kinetic energy, and it keeps on moving. and fill up the space. Yeah. So when you increase the temperature, what will happen? The intermixing will take place more rapidly. When you increase the temperature, suppose you put it on a burner, so the intermixing will take place more rapidly. Why? Because energy level gets increased. Energy level of the particle gets increased when you increase the temperature, or you can say when the temperature of the sample is increased, energy level of the particles increased. So now particles are moving at a higher speed and fill up the space. So that is the reason. So this is what I have written for you. So probably you can go through it. The particles, the intermixing of particles of, sorry, of two different two different types of matter on its own, yeah, is called diffusion. Yeah, this happens because particles of matter continuously move by the virtue of having kinetic energy, right? This is what we have discussed here. Yeah, and keep on filling up the space in between the particles. As the temperature rises, the kinetic energy of particles become higher and the fulfillment of blank space takes place more rapidly. The next question which we are going to take is, a diver is able to cut through water, okay, in a swimming pool. Which property of matter does this observation show? Right? Okay. So till now we have studied, guys, that just concentrate on this space, that in liquid, the force of attraction between the particle is lower in comparison to solid. Yeah, it is of intermediate range. We have drawn this table also, you remember. Yeah, force of attraction. So since the force of attraction is lower, yeah, so hence the space available between them is sufficient, you can say. Sufficient space is available in between the particles of any fluid. Since it is a case of water, it talks about water actually. So I'd like to highlight one important property of water. So actually, what is a special substance? Why special? Let me tell you. Because um, each molecule of water composed of two hydrogen atoms and one oxygen atoms. The formula of water molecule is H2O. So let us pay attention. So how they are formed? This is HOH. Yeah. So you can say it is this is going to be one molecule of water, and the bond which exists between hydrogen and oxygen is temporary in nature. This is very important to know. This is very important, I repeat. The bond which exists between hydrogen and oxygen is temporary in nature. This is a special property of water actually. Yeah. So it keeps on forming and breaking, forming and breaking. So suppose multiple molecules are existing together. So how they will look like this. This is how the molecules of water appears to be, and the hydrogen bond. This is hydrogen bond. This temporary bond which I talked about. This particular bond. Okay. This bond. This is temporary in nature. This keeps on forming and breaking. This is called hydrogen bond. Okay. So because of these two properties, the force of attraction between the particles is lower, hence the space between them is higher. Apart from that, this hydrogen bond, the shape of water is not fixed and the thickness of water is very low. Okay, is very low. So overall water is very thin. Okay, shape is not fixed, so that's why we can move our hand freely through it. So this is what I have written for you, so you can write this in your exam.
So in general, in general, the strength of the force of attraction, okay, between the particles of liquid is lower. Apart from that, water as a matter, okay, has a special property. The molecules of water are loosely coupled. See, this is a keyword. This is loosely coupled with each other because hydrogen bonds between the molecules keep on forming and breaking. Keep on forming and breaking, okay? So overall, the shape of water is not fixed and thickness is very low, due to which hands can pass through it easily. The next question is the smell of hot sizzling food. Yeah, hot sizzling food reaches you several meters away. But to get the smell from cold food, you have to go close. That's good. So let's try to understand this way. This is your food item, okay, which is hot and sizzling. You put it on a burner. You put it on a burner. It is hot and sizzling. Yeah. So what will happen? Aroma will come out of it. The aroma which is coming out is gaseous in nature, as it is quite evident here. Okay. So let us analyze. A sample of aroma. So what you will find, it consists of various particles, which are nothing but particles of gases, and we know the particles of gases are more energetic as the temperature rises. So that's why it will fill up the available space. But when the food is cold, very less aroma will come out of it, and the energy level of the particle will be very low, due to which it will be located very near to the food item itself. So this is what I have written as the answer of this question. So you can refer to that. The food has its aroma. The food has its aroma, which is gaseous in nature. When the food is hot, sizzling, yeah, the particles of the aroma is more energetic, because of which it travels faster in air. However, when the food is cold, yeah, the particles of aroma is very less energetic, so due to which these particles remained confined to the matter, confined close to the matter. Yeah, hence if you have to get a smell, then we have to go close to it. The next question which we're going to take is the mass per unit volume is called density. Yeah. So if I tell you what this density means to us, what it represents, basically you can say it represents thickness, how thick a material is. Okay, if you want to know that, so density is a good measurement for that. So it is asking arrange the following in the order of increasing density. Yeah, whose density is the least, and uh, and whose density is the most, anyway. Sorry, these are the list of matters. Different type of matters are available in front of you, and you have to arrange this in order of increasing density. Okay, so air, we have exhaust from chimney, honey, water, chalk, cotton, iron. So I have an approach for you. So what I planned that, so let us do you see, like, we have all the three states of matter here. We have gases, we have liquid, we have solid also. So what we're going to do is, let us separate out gases. These two are the gases, okay, fine. And this three, honey, water, or liquids, yeah, G and L, and remaining three are solid. Okay, so I have drawn an scale here, just pay attention here. Okay, drawn an scale here. So 0 to 100. So let us we know that whose if I ask you like whose thickness is the least, what you will answer? Of course it is gas. Why? Because in gases the space available between the particles are the most in comparison to this is gases, okay, in comparison to liquid and solid. They're tightly the particles are very closely related to located to each other. Yeah, since in gases the particles are far away from each other, because of having higher kinetic energy, so its thickness is low. That means density is low anyway. So let us try to deal the gaseous substances in between 0 to 20. We'll allocate values in between this two, and liquid in between say 20 to what do you say 60, and rest solid will allocate in between this. So these three different boxes. So this 0 to 20 will be used for allocating density to gases, 20 to 60 liquids, and rest for solid. Okay, so let's go and allocate value. Air and exhaust from chimney. First deal with gases. Air and exhaust from chimney. So what do you think, which one is having lesser density, air or chimney? Of course it is air. Yeah, because the exhaust from chimney contains particles, extra particles, which are part of your food items, you can say, apart from what air contains. So you can assign say 10, give it 10, and give this exhaust 20. Then let us deal with this honey and water. So which matter do you see is thicker, honey or water? Of course it is honey. So let us assign 40 to honey. We can do that. And how much value we're going to give to water? Then we should give 30. And now we are left with solid items, chalk, cotton, and iron. So which one is the least dense? I think cotton, followed by chalk, and then iron. So cotton will give say 70. Iron is the most dense material. So go ahead and allocate 100. You can allocate. And chalk in between that you can allocate 85, you can say. So now you have numerical values in front of you. So we have quantified the densities. These are not the actual densities, these are just based on our scale. So now you can arrange the substances in order of their increasing densities.